Hi guys, back again. For the last lesson, I realized after the fact that I had left a third example blank. I apologize. You guys can try that for practice. And if you're really desperate and you'd like to know what the answer was, I can post it later on this week. Definitely want you to try it yourself though as part of your practice. And the other part was some homework, some practice for homework. And I'd like you to try that as well. There was sketching polynomial functions practice that looks like this, and the answers are below. Okay, so that was all part of that package. I'd like you all to try that to help you figure this stuff out, because it's not easy. Okay, so we are on week 2, and this is lesson 2 for week 2. We're going to do a little investigation today. And we're going to talk a little bit about vertical asymptotes and X intercepts. Now, this is based on rational functions, though. Not the same as polynomial functions. We were talking about polynomial functions last lesson. Rational functions look like these. There is a numerator, a denominator, and most often a denominator, well, there has to be a denominator with a variable. Variables have to be in the bottom of these. They don't have to be in the top, as you can see, 1 over x plus 2, but there might be x minus 1 on the top here. There definitely has to be variables in the denominator, though, to make it a rational function. So here you see 3 equations, 3 functions, a of x, b of x, c of x, and you'll notice that each of these 3 have very different, peculiar shapes. And I want you to take a look at all 3 of them just to see what you notice, not only about the equations themselves, but what you see in terms of asymptotes and x-intercepts. So I'm going to have you pause the video there for a second and just have a quick look at all 3, compare them to the actual equations up here. Okay? And we're back. So if you had a chance to look at all of those 3 graphs, here's question A. What connection do you notice between the factored form and the location of the vertical asymptotes? Well, the vertical asymptotes occur when you set the denominator equal to 0 and solve for those roots. For example, here is x plus 2. If I set that equal to 0, x equals negative 2, yep, there's the vertical asymptote right there at x equals negative 2. The 2 vertical asymptotes for this graph are at negative 1 and positive 3. There they are at negative 1 and positive 3. 2 vertical asymptotes for that graph. For this one, it's at x equals 2. X minus 2 equals 0, so x equals 2. Here is the vertical asymptote there. What connection do you notice between the factored form of the equation and the location of the x-intercepts? Well, the x-intercepts occur when you set the numerator's factors equal to 0 and solve for those roots. Here, if I set 1 equal to 0, there's no x-intercepts. Interesting. Here, if I set x minus 1 equal to 0, however, there is an x-intercept right here at x equals 1. That corresponds with the numerator. Here we have 2 x-intercepts at 3 and 6. 3 and 6 is where this graph crosses the x-axis, at 3 and 6. But all of those come from the numerator, the factored form of the numerator. Next, state the vertical asymptotes of the function f of x. Well, we know that it's the denominator that helps us figure that out. So, set the denominator equal to 0. Solve, we have x equals negative 7 and x equals 11 halves. In D, state the x-intercepts of this function. Well, now we know we have to set the numerator equal to 0. And that is 3x times x minus 9 equals 0. Which tells me that from this factor, x equals 0, and from that factor, x equals 9. So we now know what those 2 x-intercepts are. Please don't confuse when I say x equals here and x equals there. These are asymptotes. These are intercepts, where the graph crosses. In part E, it says, using the x-intercepts and asymptotes vertically, determine the equation of the graph shown on the right. So, what do we need? We need to know where the x-intercepts are, and they are at negative 1 here, circle it, and at positive 3 there, circle it. It's always a good idea to circle those on your graph. That tells me what the numerators need to be. The factors have to be x plus 1 times x minus 3 for those to occur. Then I look at my vertical asymptotes and I see that I have a vertical asymptote at x equals 0 and another one at x equals 2. That's going to tell me what the factors need to be on the bottom, or the denominator. So the factors in the denominator are x times x minus 2 for those to occur. There's one last thing we need to do, is include some variable here, I'll call it k, to represent the leading coefficient, because we don't know what the leading coefficient is here. That's an unknown as of right now. We might be able to figure that out later on when we're actually solving these equations, but for now we'll just leave it as an unknown, k. That's important though. Make sure you put a k in there to represent that number. Whether it's negative or positive, we don't know yet, but we will get to that point soon. Okay, as another part of our investigation, I would like to introduce what's called an oblique asymptote. Horizontal asymptote is just a line that a graph gets closer and closer to. A horizontal line, that is, the graph is getting closer and closer to. So you can see it here. There's a horizontal line that this graph is approaching. There's also a horizontal line that this graph is approaching. It's at y equals 1, straight across. But when you look at graph C of x, there is no horizontal asymptote. There is a vertical, but no horizontal. Instead, there is an oblique, what's called an oblique asymptote, which looks like a straight line heading up this direction. It's almost like a diagonal. So I want you to, as an exercise, draw for me with a ruler. Just pause the video and draw this oblique in. See if you can do it. It's got a line that's heading up to the right, definitely, and it's a straight line that's heading up to the right. The next thing I want you to do as part of this investigation is to have a look at the equations and the graphs and see if you can figure out how they match, or what matches up, so that to figure out how we create these horizontal and oblique asymptotes. And then we'll answer part A and part B. Okay, we're back. A, looking at an equation of a rational function, how can you tell whether it's going to have a horizontal or an oblique asymptote? Here's how you tell. In order for it to have a horizontal, the degree on the top has to be either less than or equal to the degree on the bottom. For example, 2 over x minus 3, the degree on the top is less than the degree on the bottom. 2x minus 5 over x minus 3, the degree on the top is equal to the degree on the bottom. That makes it a horizontal. But for it to be an oblique asymptote, the degree on the top has to be greater than the degree on the bottom. Take a look. This degree on the top is 2. 2x squared, 2x times x is 2x squared, and the degree on the bottom is 1, only 1. And we end up with an oblique asymptote. So, predict whether each of the following functions will have a horizontal or an oblique asymptote. The first one has a horizontal, same degree, top and bottom. Oblique for the second one, a degree is higher on the top than the bottom. And horizontal for the third one, the degree is higher on the bottom than the top, or less on the top than the bottom. Keeping going with this, when you read the question, consider the following pairs of graphs and then answer the questions below. Make sure you pause the video at this point before I give the answer away, and have a chance to look at it yourself to see what's happening. Don't plow through and listen to the answer before you've actually tried to look at it yourself. So pause the video here. Here comes the answer though. A, when looking at a graph of a rational function, how can you tell if there's a square on one or more of the brackets in the denominator? So what happens is the end behavior changes and one part of the graph gets vertically reflected. Notice here, this part got vertically reflected up. So now instead of opening down, it's opening up. That's how I know it's x plus 2 squared. Something here got vertically reflected as well. In fact, this got vertically reflected. Now it's opening up instead of opening down. And these two parts actually got reflected as well. A little bit of reflection at least. So there's definitely things that are happening here. Same thing with this one. I'd like you to consider the following graphs, pause the video, think about it, and then answer this question. Why do the rational functions shown not have vertical asymptotes? Why do these not have any vertical asymptotes here? Looks like they should, but they don't. And the answer here is there is no x value that would make the denominator equal to 0. So if I tried to solve, say, this one, b, x squared plus 1 equals 0. X squared must equal negative 1. X has to equal plus or minus, technically plus or minus, the square root of negative 1, which is impossible. You can't take the square root of negative 1, which tells me that there is no possible vertical asymptote here. It is impossible to get a vertical asymptote there. As part of this investigation, we're done the investigation now. I'd like you to try this homework. There's lots of great practice here with graphs and answers. Try this, and that should be the end of week 2. Look for a quiz coming up on Friday. I will post it on Friday, but you only have 48 hours to finish the quiz. There's a few people that didn't quite get to it this week, week 1's quiz. So I'd really like you to try your hardest to get the quiz finished in that 48-hour time. Okay? Thanks, everybody. I hope you're having a great week. I hope you're staying safe, staying healthy. And this is Mr. Murray signing off.